Hello, today I'll be showing how you can use the wave equation to create water effect in your Unity project. This very nice effect is also interactable. So for example, you can simulate waves propagating out from a moving boat. So let's look into it. Let's start with a plane, which is going to be the surface of our water. We're going to link this to a wave manager script. And we're going to have a texture, which is transfer this texture the wave material. So for wave equation to work, we need to have three matrices that's going to contain the states of the wave equation in the previous, current, and next steps. So we're going to call the current one wave n, and the previous one wave n minus 1. Next one is wave n plus 1. And we're going to define the width and height of the texture. And the dx is the resolution or something else. And the dy is going to have same value as a dx. So there's no point having a different variable. We're going to use a property which is going to directly get the same value of the dx. And nx and ny, they can be the resolution. Let's for them. Let's note them what they are. They're the state information. And this is the height, width, and the height. The dx is going to, this is every step in the x axis. So we call it x-axis resolution, and the y-axis resolution. Actually, resolution is nx and ny. So we should rename the resolution. It's more like density. I suppose density would be the right thing to say. And the resolution is nx and ny. The CFL stands for Current Fredericks Levy or something. I'm not sure. And the dt is the time step. Next, we're going to start with initiating the wave texture. All three matrices needs to be initiated at the beginning, and this is the only way I know how we can initiate two-dimensional array. Since here they are, two-dimensional array. They're made of a two-dimensional array, and so every row needs to be initiated separately. And then next we need to assign a texture variable with our texture in the material. Now I'm choosing main text and displacement. These are going to be the names of the variables which I'm going to use in the shader. So I'm going to assign both of them with the same texture. Next, let's start with a wave step. This is going to contain our all calculations. So the dt has to be calculated. We can use delta time here, but I'm just going to use for now CFL dx over C. This is the only place where we're using C, so we can change our time step using the C. And we're going to have a float t, which is going to contain the current time. This is where we copy the content from the current wave state into the previous wave state, and from the future or next wave state into the current wave state. This is where all the wave equation calculations are happening. And we are going to be calculating for all the for all elements except the edges of the texture. In this step, we will be using the values from the adjacent elements. So I'm going to store them in local variables and then use them in the equation. I also need the value in the previous step. Now we need to apply our values in the matrices, actually the current matrix, onto the texture. So I'm going to have an individual function that's going to take from the matrix and apply to the texture. So I'll iterate through all the elements in the matrix. And save it as a color. So this is now a grayscale color. Grayscale. And we're going to call this and the wave step in the update function. So let's remember to apply the texture, because if we don't apply setting the pixel doesn't doesn't have effect. And make sure that you have a reference keyword beginning so we can actually change the texture. Here I assign the material to the wave material. However, I don't need to do anything about the wave texture. It's going to be created in the runtime. However, it is too dark. We want something, we want gray, because the wave is going to have my ups and downs. So we want an average value to be about the gray, to correspond to gray. This is why we're going to have a wave. Now we don't want it to flat all the time. We want to have some. We want to create some wave. So we're going to simulate droplets, and for the moment we can choose to the middle, and we're going to create continuous oscillations with the sine function. Now let's create a shader that's going to use our texture. So we definitely need the main texture and the displacement texture. And the reference here, we want to change it to what we have written in the code. So it's going to be underscore main text. And for the displacement texture, we can name it underscore displacement texture, displacement text. Now we're going to use the sample texture to be able to visualize our texture quickly. by changing the base color. That's simple. For now, that's all we want. See? Yep, we can see some wave effect happening, or something is happening. Here we can use a multiplier to enhance the depth of our wave using a float to color multiplier, so that it will directly change the color that we produce. Remember to serialize the field so we can see in the inspector. Let's create a pulse speed variable to control frequency of the pulses. We can also store the pulse position in vector2 int. Changing the frequency doesn't seem to have any effect, but actually it does. But we can't see that because there's already a wave going on inside. It's echoing between the edges. But if we were to start a fresh run with a different frequency, we will be able to see the effect much clearer. We changed from sine function into cosine function. We did that so that we can still use it with a pulse frequency of 0. Because when we use a pulse frequency of 0, then the cosine will return 1. And so that the amount of addition in the wave equation is going to be constant. Now let's look at the boundaries. Now, at the moment, we are using a reflective boundary. That's because we're not changing the values at the edges. an alternative to reflective boundary, which will be an absorptive boundary, which will mean that the wave will continue into the infinity, into the outside of the texture. Now let's make the oscillation to follow the mouse position. So all we need to do is cast a ray from the mouse position into the screen. And if there is a hit, which would of course require that our surface has a collider. And then if there's a hit, it's going to change the value of the oscillation position, and otherwise it will not make a change. That didn't seem to work because -1 is out of the texture boundaries. Okay, that's understandable. Actually, we want to change the position vector only if there is a hit. So we should change our function accordingly. Seems I have to change the angle of my camera. Let's try again. Awesome. And here is with reflective borders. Now we have to add something very crucial. It's going to be a friction. Called elasticity. That's going to determine how long before the wave dissipates. So our wave is going to lose its power in time. So we can determine with this elasticity. It could be a better name, I just couldn't think of it. So at 0.95, it's like this. 98. It lasts until, from one end to the other. It's fun to play with it. Now I'll be trying to add some displacement to our shader so that we can actually see the wave in the 3D space. After some time, I figured that I had actually a different name for the displacement texture reference. And what I'm actually doing here is subtracting 0.5 from the R value, since the all RGB values are equal. I'll just use the R value, subtract 0.5, and multiply with the wave strength that I define the shader, and then add that value to the y-axis of the position, so that any value from the texture is going to increase the height of the vertex. As you can see, when it is all white, it's already off the center. You can see the vibrations on the surface. What actually would be really nice if we had the tessellation, but unfortunately for the moment Unity shader graph doesn't support tessellations. And finally, let's make it look more like water. So I'm going to lerp between blue color to reflect water and the color of the texture. And then I will also add an alpha channel to provide some transparency. And now we can try to optimize. Now I forgot to add the alpha channel. Let's add the alpha channel. And we will need to change the universal settings to transparent to be able to add the alpha channel. Thank you for watching and see you in the next video.